Machine learning is a branch of artificial intelligence, AI, that involves developing algorithms and statistical models that enable computers to automatically improve their performance on a specific task over time, by learning from data rather than being explicitly programmed. In other words, machine learning algorithms are designed to analyze and identify patterns in large amounts of data, in order to make accurate predictions or decisions about new data that they have not previously encountered. Machine learning is used in a variety of fields, including computer vision, natural language processing, robotics, finance, healthcare, and more. Machine learning is a type of AI that involves creating algorithms that can learn from data without being explicitly programmed. The process of machine learning involves training a model on a dataset, which consists of examples of input data, features, and their corresponding output values, labels or targets. The model learns from these examples and tries to identify patterns or relationships between the input features and the output values. There are three main types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, the model is trained on a labeled dataset, where each example includes the input features and the correct output value. The goal is to learn a mapping between the input and output variables, so that the model can accurately predict the output for new input data. Examples of supervised learning algorithms include linear regression, logistic regression, decision trees, and neural networks. In unsupervised learning, the model is trained on an unlabeled dataset, where there are no explicit output values. The goal is to discover hidden patterns or structure in the data, such as clustering similar data points together or identifying the principal components of the data. Examples of unsupervised learning algorithms include K-means clustering, principal component analysis, PCA, and autoencoders. In reinforcement learning, the model learns by interacting with an environment and receiving feedback in the form of rewards or penalties. The goal is to learn a policy that maximizes the cumulative reward over time. Reinforcement learning is often used in robotics, game playing, and other applications where the model needs to make sequential decisions. Machine learning is a powerful tool for solving complex problems that would be difficult or impossible to solve using traditional programming techniques. It is used in a wide range of applications, from image and speech recognition to fraud detection and drug discovery, and has the potential to transform many industries in the years to come. Machine learning is likely to play an increasingly important role in the future. The ability of machine learning algorithms to analyze and make predictions based on large amounts of data is already transforming many industries, from healthcare and finance to transportation and manufacturing. Machine learning has the potential to revolutionize the way we approach many problems, enabling us to develop more accurate and personalized solutions. There are several factors driving the growth of machine learning. One is the explosion of data that is now available in many industries, which provides a rich source of information for machine learning algorithms to learn from. Another is the development of more powerful hardware and software tools that enable faster and more efficient machine learning algorithms. In addition, there is growing interest and investment in machine learning from both academia and industry. Many companies are now investing heavily in machine learning research and development, and there is a growing community of researchers and practitioners working on advancing the field. However, it's important to note that machine learning is not a silver bullet and there are still many challenges that need to be addressed, such as data privacy, algorithm bias, and ethical considerations. Nonetheless, it's clear that machine learning is already having a significant impact on our lives and is likely to play an increasingly important role in the future. Students can learn machine learning through a combination of theory and practice. Here are some steps that can help. 1. Learn the basics of programming. Machine learning requires a strong foundation in programming, especially in Python. Students should learn the basics of programming, such as control structures, data types, functions, and classes. 2. Study the theory of machine learning. Students should learn the fundamental concepts and techniques of machine learning, such as supervised and unsupervised learning, linear regression, logistic regression, decision trees, random forests, support vector machines, clustering, and neural networks. There are many online resources, courses, and books available to help students learn these concepts. 3. Practice with datasets. Students should practice implementing machine learning algorithms on real datasets. They can start with small datasets and gradually work their way up to larger and more complex ones. 4. Use machine learning libraries. There are many popular machine learning libraries available in Python, such as scikit-learn, TensorFlow, and Keras. Students should learn how to use these libraries to implement machine learning algorithms and analyze data. 5. Participate in competitions and projects. Students can participate in machine learning competitions on platforms such as Kaggle, or work on machine learning projects in areas that interest them. This will give them hands-on experience and help them build their portfolio. 6. Learn from others. Students should join machine learning communities, such as online forums or local meetups, to learn from others and get feedback on their work. Overall, learning machine learning requires a combination of theory and practice, as well as a willingness to experiment and learn from mistakes. It can be challenging, but also very rewarding, as machine learning has the potential to transform many industries and solve complex problems.